So in this video, I'm going to do a complete overview of how to solve systems of linear equations using the elimination technique. So I'm really going to make sure that you have kind of seen the breadth of examples and give you a chance to practice some of it. So hopefully you feel like you've got a really good handle on this technique when we're done. I highly recommend that you pause and try the examples when I suggest, because math is not a spectator sport, so it's not enough just to necessarily watch a video. So pause and try just to make sure you've really got it. And there are free guided notes available at divideandconquermath.com. So this example is kind of like the ideal case of elimination. It's kind of like if there was like an easy example, I'll show you what makes this like the easiest way to do this. So the thing I want you to notice, I've got 3x minus y equals 8 and 2x plus y equals negative 3. So here's the thing I want to point out with this. This is why this is what makes this particular example like kind of one of the easier ones. Notice this relationship between the y's. One is negative, one is positive. So when that happens, you are like in the ideal setup for elimination, and it makes it very quick to get through. And so the idea behind elimination is, so when this happens, so when you have that one variable is kind of the additive opposite of the other, you can just add these straight down. So we're just going to kind of add like this. So I've got 3x plus 2x, so that's going to give me 5x. Then notice what happens with the y's. Negative y plus y means that there are no y's. So those just cancel out entirely. So I'm just going to skip it. And then 8 minus 3 is 5. And so here, like, look, we're almost done already. So this is why elimination is nice, and this is what makes this particular type of example kind of like easier. So now you can finish solving for x. So you can divide both sides by 5 to get x equals 1. And so if you've been watching other videos on systems, you probably know what to do from here. So now you want to solve for the other letter. So you solve for the first letter, so I've got x, and now I got to solve for y. And to do that, I plug this back into either one of these equations. So I'm going to have 3 times 1 minus y equals 8. So I decided to plug this 1 into the first equation, and now I'll go through and solve for y. So this becomes 3 minus y equals 8. So I can subtract the 3 from each side. Continue over here. So this is negative y equals 5. Divide both sides by negative 1 to get y equals negative 5. And so my solution here then is going to be 1, negative 5. And you can prove that to yourself by plugging this back into each equation. And if it works in both equations at the same time, then you know you found the solution. Okay, so just to make sure that you've got kind of the basic idea here, I recommend that you pause the video here. This is kind of a quick example, so you can pause here and try to solve this one entirely, and then hit play when you think you're ready. Okay, so once again we have that same like little relationship where these two letters are just ready to be knocked out if we use this technique. So what I'm going to do is I'm going to just kind of add both of these together. So adding straight down, so 4x plus 3x is 7x. The y's drop out, and then I've got negative 6 plus 6 is going to equal 0. So if I solve for x, then I just get that x equals 0. So now I need to plug this back into either one of these equations. I'll plug it into the second equation just for funsies. So I have 3 times 0 minus 2y equals 6. So this gives me minus 2y equals 6. Divide both sides by negative 2, and I get y equals negative 3. So you always want to state your solution as an ordered pair, so this will be the solution 0, negative 3. So now we're going to move on to slightly more complicated examples. So starting with this next example, I've got 3x minus 6y equals 6 and 5x minus 2y equals negative 14. So the thing I want you to notice here is that I can't just go in and do the elimination technique right now. So I don't have anything that's going to nicely cancel out. So we're going to have to manipulate one of these equations so that we can still use elimination. And so the thing that you want to think about is there one equation that you could multiply by something so that your variables would drop out? And so as you think about this, so notice this is negative 2y. If I multiplied this by negative 3, that would give me positive 6y, which would then allow me to cancel these two things out. So you have to think a little bit ahead. So that is kind of the path of least resistance here. So what I want to do is I want to note that. So let me actually switch this to green. Multiply by -3. And by the way, I highly recommend that you kind of write out little notes like this when you do this, because it makes it very clear what it is that you're doing. It makes it a lot easier for your teacher to grade. It also makes it a lot easier for you to remember what it was that you did versus just jumping right into it. Okay, so I have to multiply this entire equation by -3. So 5 times -3 is -15. And then -3 times -2 is +6, is +6y. And then -14 times -3 is 42. And now I have exactly what I need, right? So I can go ahead and combine these. So what I would recommend that you do here actually is that you pause the video and now you finish this one and then you can check it when you're ready. So go ahead and give that a try. So if I go ahead now and add these, so this is -12x, the y's drop out, and then this is going to equal 48. Okay, so now I'm good to go here. So I can go ahead and divide both sides by -12 to get that x will equal -4. And now I need to solve for y. So I can plug this value into either equation. I'll plug it into the first equation. So I get 3 times -4 minus 6y equals 6. So this is -12 minus 6y equals 6. I'll add the 12 to each side to get -6y equals 18. Divide both sides by -6 to get y equals -3. So my solution in this case, I'll write it up here at the top, -4, -3. And then once again, you can always just plug that back into the equations just to check it, but that's the idea there. Okay, so now I want to show you kind of like the most complicated example, I guess, that we could really have of this. So notice in this example, 5x minus 10y equals 5 and 2x minus 3y equals 6. I can't do elimination. And as far as having like one number I could multiply by to do elimination, it's not like I can multiply 5 by something to make the x drop out or 3 by something to make the 10 drop out. So what you have to do in some cases with elimination is you have to multiply both equations by something. And when that happens, then it's really just whatever numbers you think might be the easiest to multiply by. So I see this 5 and this 2. So if I multiply this equation by -2 and this equation by +5, I'll get that relationship. And by the way, I could have multiplied this by +2 and this by -5. It doesn't matter which you multiply by. Now it's just, whatever kind of makes sense to you, I guess. So for our purposes, I'm going to just note here, so we're going to multiply by -2, and we're going to multiply by 5 so that I can have the x's drop out now. So multiplying by -2, so this will be -10x plus 20y equals -10. And then the other one, 10x minus 15y equals 30. Okay, so now we can go ahead and eliminate, right? Because now I've got my -10x, +10x, so this is exactly what I wanted. So now I can go ahead and finish this. So maybe, once again, just for extra practice, you could pause here, finish, and then hit play when you're ready. So as I eliminate, so now I get 5y equals 20. Divide both sides by 5, I get y equals 20. So, oops, sorry, y equals 4. Okay, so now let's plug that into, let's plug it into the first equation. So I've got 5x minus 10 times 4 equals 5. So this is 5x minus 40 equals 5. I'll add the 40 to each side to get 5x equals 45. Divide both sides by 5 to get x equals 9. So my solution in this case will be 9, 4. And so that's how you would approach that one. Okay, so now I just want to pivot to what happens in the cases where you either have no solution or infinite solutions. So I think what would be best here actually is to have you try these. So you go through the whole thing, something strange will happen. So just work through it as far as you can, and then when you think you've got it, hit play. So as I look at these equations, so I see I've got 5x minus 2y equals 1 and negative 10x plus 4y equals 3. So I notice here, if I just multiply this equation by 2, I'll be able to eliminate. So I'm going to go ahead and just multiply by 2 to get 10x minus 4y equals 2. And then I've got negative 10x plus 4y equals 3. So notice what happens now when I eliminate. Well, the x's drop out, but so do the y's, right? So actually now on the left side, I just put a 0 here. And then on the right side, 2 plus 3 is 5. So we know then when we get a solution that doesn't make any sense, 0 equals 5, that's not true. The interpretation is that this would be no solution, or you can use the empty set notation. Okay, so let's contrast that to this other example. So once again, I highly recommend that you just pause the video here, try to work this one out, and then hit play when you're ready. So in this case, 3x plus y equals 5 and negative 9x minus 3y equals negative 15. Well, the best route to go here would be to multiply the first equation by 3. So now I have 9x plus 3y equals 15. Negative 9x minus 3y equals negative 15. So if I add these all together, once again the x's will drop out. So this is going to say 0 on this side. And then 15 minus 15 is still going to be 0. Now this is a true statement that 0 does indeed equal 0. And we've talked about this in the past. So when you get this type of situation, this means that you have infinite solutions. But of course, when we have infinite solutions, we need to be able to represent our answer in set notation. And so then what we need to do is look at these two equations. Which one looks like it's going to be easier to solve for y? Well, I would say in this case, this one looks like it's going to be easier. So I'm just going to write that over here. So I have 3x plus y equals 5. So to solve for y, all I need to do is subtract off the 3x. And so that's what I can use for my infinite solution. So I'm going to have this set notation xy such that y equals 5 minus 3x. And so that'll be my final answer. And okay, so that brings us. So I'm going to leave it at that, and I'll talk to you guys in another video. Peace.